So we're looking at solving equations, okay? And we talk about equations in many fields of math. And I want to dedicate this video to equations that relate to formulas. We call them literal equations. And we have abstract equations. And some of these are multi-step equations too. But here's what's unique about them, is that you have letters. And I ask you to solve for a given letter. So for example, the area of a rectangle, if you're trying to buy carpet for a rectangular room, the area of the rectangle is length times width. And if you know the area in the room, or if you know the area of a specific piece of carpet, but you're trying to figure out the length and the width that will be required to put that carpet down, you'll use the formula A is equal to L times W. Okay, length times width or length times breadth, depending on how we say it in British English. And so when we find the area, A is equal to L times W. If I give you the values, so let's say I give you this as 10 and this is 5, we're just going to call it units, then A is equal to 10 times 5, or actually I reverse my values, so we have 10 and 5. This is not drawn to scale. But if you have 10 times 5, then that will become 50, correct? So 50 units squared. But let's say I don't give you the values, and such that I change that now to just the area. The area is equal to 20. And I tell you that the width is 2. This is not drawn to scale. And I don't know what L is. Okay, so then you would write A is equal to L times W. Because you're solving for L, you would divide both sides by W. So L is A over W. Okay? Now notice that if you were doing 2x is equal to 10, you would divide both sides by 2 and get x is equal to 5. The principles are the same, remember, my friends. The principles are the same. You just need to know how to use them, and then it doesn't matter what you're giving, you can use it in whatever context. So let's look at another example with like a circle. With a circle, we know that the radius is half of the diameter, okay? And we know that the circumference is when you go around, and the area is everything inside the circle. So the area of a circle is pi r squared. Well, let me show you something interesting with equations, okay? If the area of a circle is pi r squared, and the circumference of a circle is 2 pi r, do you know that you can use equations to play around with some of these variables and see what happens? Well, we're going to look at that quickly in this video. But before I do that, I want to remind you that when you solve equations that just have letters, you use the same principles like the principles you use when you have numbers. So let's see what's interesting here. So pi is used in the formula for the area, and pi is used in the circumference. What if we wanted to see if there's another relationship between the area of a circle and its circumference? So let's solve for pi in the first equation. So A is equal to pi r squared. We're going to divide both sides by r squared. So pi is equal to A over r squared. Now, okay, that's straightforward. We divided both sides by r squared. Now, the circumference is 2 pi r. If we're solving for pi, we would divide both sides by 2r. Again, because that would cancel the 2 and the r. So that means C is equal to C is equal to 2 pi r, C over 2r is equal to pi. Okay, so if pi is equal to A over r squared, and pi is equal to C over 2r, that means by the transitive property now, and you study some of these as you look at geometry, that means that this right here is equal to that. Because pi is equal to pi. So whatever the contents of pi are, we can set them equal to one another. So let's set those equal. And we get A over r squared is equal to C over 2r. And let's say I want to just put everything, make it a linear equation. Well, just a linear format. Let's just put it all in one line. You can multiply both sides, okay? So you get 2r times A is equal to C times r squared, okay? So I multiply both sides. Again, we're just trying to see what equation solving can help us do. Well, then I'm going to divide both sides by r, because they both have r's, okay? On the right side, you're going to have only C times r. On the left side, you're going to have 2a. So, the area of a circle times 2 is the same as the circumference of the circle times r. That's very interesting. We just showed that using equation skills, and we can see that 2a, 2 times the area, is equal to the circumference times the radius of that circle. So equation solving can allow you to see many opportunities, whether you're dealing with formulas or you're dealing with numbers. You can use equations to figure out the details for building and construction. So let me leave you up with a few, one more example as you master this principle. And this example comes from graphing. When we graph lines in mathematics, okay, when you're dealing with the equation of a line, and we will have more videos with this, you notice that that's your origin. This right here is called the slope-intercept form. And so if I give you an equation like y is equal to x plus 5, what that means is you go up to 5, and that will be the y-intercept. That's what b stands for. And the slope is 1, of course, because it's 1 times x, which is just x. But so the slope is 1. So for every time you move up 1 unit, you move to the right 1 unit. So we can draw the equation of this line. We can draw the line using the equation that we've been given. But what I want you to note is whenever you're asked to graph a line, if I give you 2x plus 4 is equal to, or 2x plus 4y is equal to 10, you have to solve for y. Typically, we would prefer you to solve for y, which would then put it in the slope-intercept form before you can graph the line. So, why do you need equations? For solving many things that involve formulas. And one other thing is because it will help you know and do well in graphing lines. So master this and seek to teach other people and encourage them as they seek to learn it as well. Thank you very much.